There we go. Okay. See if I can sort of see the camera. Yeah. Okay, we're going to go ahead and get started. This is easy. We have a small crowd here. A few people remote as well, including our presenter. Rowdy, you'll have lots of good questions. So my name's John Henkel, as it says there. I'm one of the managers here in the SMPTE Sacramento chapter. This will be recorded, as it says, and there's the link. I had to find out myself. If you're curious where these things are, that's what they are. SMPTE.org, sections Sacramento. You'll find this. There's the board members. That's right, Polly's off somewhere, gallivanting around the world maybe. Mona's here, Bob Huddleston's here, Tim, myself, Robert, and John as well. Two Johns. Major point elections are now open. So voting members will get an email, apparently, from SMPTE, and you will then get a link to vote for us or for others, if you so desire. That's a big thing to make sure you take part of. And then other things, I'm not going to spend too long on these. We do this every month or so at these meetings, but here are some benefits you may not know about. Check them out. There's a lot of good things they're doing at SMPTE these days. I know a lot of it is the membership levels. And I went back over this pretty quick, but there are multiple different SMPTE membership levels if you aren't aware, but here probably is aware. And then they now started the monthly dues. So there are ways to do this at a much cheaper rate per month. And that's what those monthly rates are. And those are some of the benefits you can get those on the website, of course. So I'm not going to spend too much time here. Let's jump right to this. Let me just clear the picture here. So tonight we have a friend of mine, actually, Jeremy Hochman, and a quick little story. When I spent about 10 years coming up here for Grass Valley Group and Grand Patent Audio Systems, Renegade Labs. My first job back, Jeremy, if you don't remember, was with you at Element Labs in 2007. So he took a chance on me and actually got me to where I am now. So I owe Jeremy a lot. We've kept in touch since then. He's an amazing person, a kind person, but also extremely brilliant. And I'm really happy he can be here tonight. If you haven't heard of Megapixel, they're pretty phenomenal large screen displays. He'll tell you about some of that. The key, I think, is really their image processing. And that's where Jeremy comes into play. Besides great attention to industrial design, but the image processing that they have on Megapixel, they use for other systems around different areas. So like he and Jed were talking about NAB coming up. Megapixel screens will be at, what, a half a dozen different booths maybe? At NAB?
Yeah, at least.
Yeah. So the screens and processing is used for other displays, and separately the display processor on its own. So together it's a pretty cool combination. Jeremy knows everything. Well, you know a lot, I'll put it that way. And tonight he's going to talk to us about SMPTE 2110 and their use of it. And in fact, me being a Netgear also is special because they use a lot of Netgear switches. So I'm very happy to turn this over to Jeremy. And recording is on.
Awesome. Thanks, John. Appreciate the intro. I'm going to get my screen shared here. Yeah, so as John mentioned, I'm founder of a company called Megapixel. My team has actually been in the AV and LED video space for over 20 years now. So we've, as an engineering team, actually moved to through a couple different companies, and that's how I know a lot of people in the industry. But Megapixel was founded in 2017. With a lot of great industry knowledge, bringing the team together. When I was talking to John a few weeks ago, he was asking me to talk about 2110 and kind of how it relates to virtual production, which we're very involved with on a daily basis as part of our business, as well as broadcast and live events. So I'll talk about a few of these things. Virtual production over the last few years has obviously been quite a topic of buzziness because not only are movies using it, but it's starting to make its way into broadcast studios and even like XR for live events and these kinds of things. Sports has adopted it pretty well. So I want to back up a little bit and give some history on that because at least for the reason that we liked SMPTE 2110 and some of this interoperability, it was solving a lot of problems that we've had in the past. So I'm going to go through the past so that we can understand what's coming in the future. So let's look at how virtual production in particular started. So my journey starting in this was in 2005, and the date note is 2005, not 2015. So this is just about 20 years ago. We were working on a music video called Speed of Sound for Coldplay, and we rigged LED video-driven fixtures onto some C-stands and used these as key lighting. And so we ended up liking the dynamic effect that video were putting onto talent's faces. This was using film at the time. And it gave us a very interesting, unique atmospheric effect, being able to have lighting that was video driven. And so to our knowledge, this is the first video driven key lighting used for anything that was remotely cinematic. And so this then kind of opened a lot of experimentation, a lot of doors for trying things on camera. So shortly after this, this was with the same director of photography as a music video, the late Harris Savides. He was working on pre-production of a movie called Zodiac with David Fincher, and they invited me to come down and do a camera test. We did the camera test inside of a box truck at a hardware store, and it was very successful. And so the next day, we actually brought the same lighting rig into the studio in Hollywood. And so what you're looking at here is the final movie footage using this dynamic lighting effect. And so this was time code, audio time code, driving video plates playing back through the LED fixtures. And of course, you can see the composite here, and you got a very nice natural lighting effect on the door sills and on their faces, that sort of thing. From there, this was successful, and so we started thinking, okay, well, we can do trains and buses and airplanes and things to get bigger. So for Curious Case of Benjamin Button, this was in 2008. This was the largest array as of that time. We did the same setup from Zodiac, but just much, much longer for the train car. And this was also the principal key lighting for all the sequences in this movie. Off to the side there, I've got a picture of my laptop. This was at the time a MacBook Pro that was DVI output going into one of our proprietary LED processors at the time. It was probably running a resolution like 1024 by 768, which we would have considered like really, really high resolution. But that was the control system. That was it. I had, I think, a little Motu time code converter that went to MIDI that was then driving the playback. So every time, just like on Zodiac, every time audio would record, an audio department would start their time code, it would basically scrub through the video. So it was a pretty unique system, and they could even rewind a little bit, and you'd see all the video rewind. But today, when you see behind the scenes, there's an enormous amount of operators with workstations. But back then, all we were using is a laptop, and so that's a side note. Something that we're trying to get back to is simplifying this process, even in large volumes, to make it a little bit easier to operate. So coming out of the success of that, we started doing larger, they weren't called volumes back then, but we were calling them boxes. And so the light box from Gravity became pretty well known. This won a visual effects Oscar for the work that went into this. So this was at the time, I believe 9mm LED. Some areas we used diffusion, some not, but it was really the only way to capture everything in camera to get all of the lighting conditions on the helmet and the spacesuit and reflections and eyeballs and that sort of thing. Then we started getting a lot bigger. So this for Rogue One in 2016, this is one of the earliest drums that we put together. This was a lot of different companies working together to pull this off. So this was together with ILM, with Lux Machina. This was LED panels provided by VER at the time. But this was a very large setup that was the first time that we really like wrapped around scenic. And so the camera actually was not pointed at the LEDs. The camera was pointed at the spaceship. and the LEDs were there for all of the reflection in the windshield and the helmet and visor and that sort of thing. There was a lot of play kind of that went on with diffusion to get the right lighting dynamics as well. Sometimes the DP wanted a little bit softer light or something, more diffuse and maybe not as much dynamic range as we could have gotten. And so if you look closely, like down the center, you see a kind of a stripe. That's actually a shower curtain that was stitched together and hanging. So a lot of this stuff is kind of like the Wild West, and we just try different things. And if it looks great on camera, it looks great on camera, and that's what matters. Then we moved on to LED in camera. This is the first time that LED was used for a significant part of a backdrop. We built basically an LED tunnel for Murder on the Orient Express back in 2017. This was already at the time dual 8K to get such a long feature of LED. So we were already working with pretty large resolutions. But almost this entire movie was filmed in this train car set with LED. So this was really, really successful. This also was using film. Then 2018 for First Man, we also saw an Oscar for this one. This is the first I would call modern volume. Same principle was used for Mandalorian a couple of years later. From this, and largely the same team executed it as well. But this was in camera. Camera sees the LED. Camera sees the the talent, and as much as possible, we were getting in camera capture. People sometimes today refer to it as final pixel. It was 100% final pixel, but it was pretty darn close to compared to anything else that we had done before. So then when we fast forward to today, some of the largest LED volumes in the world we've had a big part of, Trilith in Atlanta and Nant Studios in Melbourne. Fun fact, at 24p, the Nant Studio has processing capacity for 4.1 billion with a B pixels. So they have a lot of processing capacity in that stage and can bring all kinds of LED in there to supplement what they have, but it's the largest volume in the world. Pretty impressive facility.
And Jeremy, what kind of pixel pitches are you talking about there?
Good question. This one is largely in the 2.6, 2.8 millimeter range. A lot of what got popularized for that resolution, this kind of like mid 2 millimeter range, was from our deployment of First Man, and then with Mandalorian. These needed to be physically large sets because they were bringing in like spaceships and airplanes and those kinds of things. And so the scenery and sets were physically very large, which meant that the volume needed to be very large and the distance between the camera and the LEDs is quite far. And so this is a suitable pixel pitch, and we're typically running like way more than 8K or 16K resolution on these things. Today, we see quite a mixture of these large volumes that are sort of like, this is a permanent one, it's a hero type volume, but there don't need to be a lot of these because there aren't a lot of Mandalorian and First Man type of things going on at the same time. We're now also seeing either a lot of temporary rentals or pop-up volumes or things that are smaller where, the scene is somebody sitting on a park bench talking to a friend, and there's a practical tree and some foliage and some furniture brought in, but otherwise the focal distance is pretty small, and those are approaching more of like a 1 millimeter, 1.5, 1.9, and in that the camera can get a lot closer to the LEDs, and therefore the size of the volume doesn't need to be very big, so you can actually do a lot with a wall that's like 25 feet wide. You don't need something that's 100 plus feet. So all of this is a long time in the making, but it's not been without its challenges and hurdles and like crazy pain points. We're moving tons of video data around, and most of the video data and metadata, there's no bidirectional data. It's just single direction over DisplayPort, SDI. HDMI, et cetera. And there's so many connections and conversions needing to put all of this together because it's a lot of HD or a lot of 4K sources that are getting stitched together. And so we don't necessarily have all of the metadata translating and getting through all of the equipment. Or if it does get through, we don't always trust it because it's so many different things. And there's just a lot of conversions in the way. And so the way that we have looked at moving a lot of video data around easily is networks and our Helios processor. So one of the things that we started to see back 10 years ago, so I'm going to rewind again a little bit. We started on a project back in about 2014 for MGM Cotai. This is a permanent installation. It's not broadcast, but it was 27 4K rasters under a single roof. And every screen you can see is a different shape and size, different orientations. It's a massive, massive public space. And we really wanted to figure out at this time, how could we bridge the gap between like IT telco equipment that was a fiber network and video systems. And so we invented a new way to transport video data over IT equipment 10 years ago. And so this was our development process and path between the processor and the LED tiles. And so that's kind of our special sauce as a company is doing this translation and being able to run tens of thousands of video nodes like they're little IoT devices at the end of a network. But that doesn't always solve what's upstream of us because we have to take in baseband video that are standards. And so back then, of course, there was no IP streaming video the way that there is today in an uncompressed manner at very high pixel counts. So when we look at these traditional data paths, we have a lot of serially connected devices. You've got your footage that's playing back in a server, so that might have ingest coming off of hard disk. We're going through typically a video router that's going into an LED processor or some kind of video wall processor. There's Genlock that needs to be synchronizing everything. And then if there's a camera involved shooting the LED, there's DIT as well. And all of these functions are interrelated and they all need to understand and share metadata. And this can really easily break down with baseband video. So my very typical example is looking at, Rec 709 and Rec 2020. Which red is correct? Which blue is correct? I don't know if this is showing properly through the monitor that you're seeing there, but one of them should look Rec 709-ish, and the other one should look saturated. And it's not to say that one of them is right or wrong, but you need to know which one you're supposed to be showing because they look vastly different. And so if you have an entire camera chain and you have mastered content that is in a specific color space and you're expecting a gamut to come out of the display, you need to know exactly what you're expecting to see, and it needs to be tagged properly. So all of those points between these serially connected devices, I view as basically they're failure points. Not only are they failure points of video not working, but they're metadata failure points. And we see this very often where a device may tell us that it's something simple like limited range, but it's actually sending us full or vice versa. And part of that is just in our industry, there's not as much software testing as you would hope. We're building high reliability equipment, but we're not launching the space shuttle. And so this kind of communication on the wire breaks down sometimes. And so on our side, we have ways of retagging things if they're coming in incorrectly. But really what solves a lot of this problem is 2110, because now this data path is very clean and we don't have all of these serially connected devices. Everything can be connected to a core switch. And so we don't have this like multiple hop scenario where if one piece of equipment fails, the whole system goes down. So this means that the video router really is an Ethernet switch. They kind of combine almost into the same unit. but footage can be connected to there. All the media servers, our LED processor, the LED wall, cameras, everything can be part of the same network and controlled. And it means that everything can talk to the other equipment as well. So to give Megapixel a little plug, we launched 100 gig support last year. So this is in the form of a little modular card that goes in. So our infrastructure is a 1RU appliance. It's capable of running 8K 60, but it's bandwidth based, not raster based. So what that means is that we care about roughly 32 to 35 million pixels at 60 hertz. And if you want to send us 32K wide for some big drum, we'll happily ingest that. And with the 100 gig coming online last year, what's amazing is we pre-tested with a lot of manufacturers, and so a lot of like the Matrox Convert IP and all of those boards, the OEM stuff that goes into other workstations as well. That's all immediately compatible. NVIDIA and Mellanox are compatible, and what we co-developed together with NVIDIA and Unreal is actually a 100 gig fiber link direct. That's able to DMA from GPU textures straight into our Helios processor. So you're able to take like Unreal Engine rendering fiber direct into the LED wall and completely bypass all baseband video. And this is saving a significant amount of frames, which in a volume where you're doing virtual production, XR, or anything that's tracked with a camera. If any of you have used cameras with LED with tracking, you know that as you start moving the camera, the video frustum in Unreal is following you like maybe 7 frames delayed. You've got to be really careful about moving it. And so we're significantly faster. And so it's giving more creative freedom to people to pan more and do more interesting things. And so with the reduced latency, we have less interconnects, of course, because everything is connected to the core switch. We're seeing very reliable metadata generally everywhere, which is fantastic. And then on top of this, because we're going through switching equipment, there's great IT-centric monitoring. So on the video side, we monitor everything, but then other people can build things on top of APIs for switches, and you can really know what's online, what's offline, and not have to be into every little piece of equipment being proprietary, which is awesome. One thing I won't specifically go into a lot of detail on, but I just want to flag this as being important, is that once everything is on a network, we can start to think about the ecosystem as more than just video and cameras. We can think about lighting, audio, pyro, and fog, and rigging, and tracking systems, even comms. So the network is extremely flexible and allows so many different types of things to connect to it. It's really, really useful. So I'll give a couple examples of things that we've been working on lately that not all of these are 2110, but they either will be or should have been if it was existing at the time. This is definitely all 2110 compliant. We're doing an interesting thing together with KinoFlow. We developed an LED fixture with them using 5 primaries. So instead of red, green, blue, we're using red, green, blue, and then 2 phosphorus whites. We're using a 2700 Kelvin and a D65 phosphor. What these do is they give us broad spectrum, and on a per frame, per pixel basis, our processing system will actually determine how to light up those 5 primaries to create the broadest spectrum possible to illuminate skin, because LEDs are very problematic illuminating skin tones. They're fine for lighting a hard object that's white. You can get great reflections on a helmet and sunglasses and those kinds of things, but skin tones are really, really difficult. And so having 2110 here is amazing because we have bidirectional metadata, and we're able to actually query the individual LEDs and all the calibration data that's on the fixture itself. That comes into the LED processor, and then the processor in turn can share that to a render engine. And so the entire pipeline is aware of what the color fidelity is all the way through the chain on a per pixel basis if somebody wants to know it. So really, really interesting tech, and pushing boundaries and really moving this forward to get just more realism. Now, totally flipping things outside of film is just cool experiential stuff. We built some robots for Adidas and Prada to launch a new shoe. This is LED kind of with a volumetric looking render on two KUKA robots. And this was just a really fun project to work on. But one of the things is that with traditional video, it would have been impossible to do this because there's so much cantilevered weight on the robot arms. We had to remote all the power supplies, but all the data also needed to be remote. So we had just very, very thin Cat6 cables running through the robot arm to the actual LED panels. And this would not have been possible without an Ethernet infrastructure because of the weight support that could be supported by the robots. And then today, every sports broadcast for NFL is at the Fox NFL Sunday studio. This is a virtual production volume that consists of an LED floor and then a wraparound walls as well. There's actually 4 cameras that are tracked simultaneously, and they're able to cut between cameras. So very typically when you see virtual production done, only one camera can be used because you have a perspective for that camera that's rendered in Unreal or Unity or Disguise. And you need that one perspective. If you have a second camera pointed at the LED wall, it's not going to have the correct perspective in the LED. We have a very special feature that we call Ghost Frame, which is a software tool set that runs inside Helios, and it times itself with multiple cameras. So you can have up to 4 cameras, each camera with its own render engine, its own camera tracking, and its own forced perspective. And the video director can actually cut between cameras without it looking incorrect. So this is really, really interesting. And again, being all network connected and having bidirectional metadata, bidirectional communication between all the devices is absolutely key for this. Also, for interesting theatrical things, we installed a screen in Cotai. This is actually the same facility that I showed that original video of, that like massive space with all the screens in it, in that kind of shopping mall area. This is a theater that's part of the same facility. It's a dual 8K theater, and at the time it installed with SDI. It's getting actually upgraded right now to 2110. But this is really like a state-of-the-art type of facility that gives a mega canvas really for whatever imagery somebody wants to throw out it. It's got a lot of motorization, as you can see, not only for the screen, but also the seats. And it's running native fiber optic everywhere to control everything. So this to me really is where the future of displays and experiential video and all of these things, as these technologies are crossing over, networks really are key, because they're allowing so many different facets of media production and different departments to actually start talking to each other. And there's more creativity happening because of that. So those are my slides. I appreciate everybody listening.
Cool stuff, Jeremy.
Thank you.
Come a long way in 10, 20 years. Yeah. Any
It's pretty amazing. Yeah.
for the group? And a couple guys online as well, Jed and Andy, if you guys have questions. Holler away. You stunned them all. Yeah, I know when I started. Yep.
For the multi-camera volume set we're talking about, is there feedback from the switcher to the video processor, like when there's a hot cut going to happen, to change the entire monitor wall, or do you multiplex in like sub-frame increments and only have the camera shutter open during a certain period of that frame?
That's a good question. Both methodologies can be used, but in that particular installation, and this is what we're seeing most of the time for these now, we are multiplexing the the video. So those panels are actually running upwards of, I think in that particular set, about 960 frames per second. The 4 cameras are each dialed to a 90-degree shutter angle, and we're able to time the LEDs to the camera. So each of the cameras has its own Genlock offset, and then we're using subframes on the LED system to time to the open shutter duration of each camera. So all 4 cameras are always seeing their own perspective all the time. And so if they decided to do like 4 streams out on 4 different channels, or they wanted to do a 2-up or a 4-up on screen, they could actually do that.
So how do the actors position themselves in that volume set? Because that just has to look like a blur of the humans on the set.
Yeah, so there are a couple functionalities that we have in there as well. So one of the things that we can do is for the subframes, we just because there's 4 cameras and 4 render perspectives doesn't mean that we only have 4 subframes. So depending on like the set that they choose or the camera setup for the week, they actually have the ability to run one of the subframes at a much higher intensity than the others. And so the perceived in place set for the actor is the one that's more dominant, although they do see like a little bit of blur with the other ones. We also have a technology that is part of the package that they have installed there that actually lets us cancel the video feeds that we don't want the talent to see. And so if you think about human persistence of vision and the fact that we see slower than, and our brain interprets images slower than LEDs can flash, we have the ability to show the let's say camera A perspective, but then immediately after that, the LED tile via metadata can be told to display the inverse negative of the video that it just received. And so the in-person experience is that there's a gray level rather than a video feed. And so we have the ability for only one of the feeds to be perceptible in person, and all the other feeds basically are canceled out with this trick of inserting a negative frame. And what those do is that they raise the in-person black level because we're generating more light. So you get a scene that just looks a little bit washed out in person, but it's not confusing because you only see one set.
Thanks.
And we'll have a version of that running at NAB. I believe at the there's a stage set up at the B&H. There's like a pavilion or something sponsored by B&H. So if you're at NAB, definitely come check it out.
Talk about the processing you have to do for getting video to LEDs. We've done it for so long, raster mapper, I think, go back some of the years, but what's involved in that, getting a video signal, breaking it up and sending it out to the individual LEDs?
That's a good question. So one of the things that we do that's really special in our processing system is that we're basically ingesting video and then dumping it onto a network as quickly as possible. But one of the things that we don't want to do is we don't want to burden the network with uncompressed video on every single link just because there's a raster coming in. And so what we do is we have a mapping utility that's built into a web server on the unit. It'll bring the video data coming in. Let's just say for argument's sake, it's 8K. That 8K raster is a lot of pixels, but maybe our LED wall just wants to look at a region of interest for those pixels, and we don't need all 8K. We've got 720p worth of LED panels, and each LED tile, the panel may be 100 or 200 pixels square. What the processor does is it actually will look at the incoming video graphically. You're able to scale the video, of course, so we have a front end scaler. And then after the video is scaled, the video tiles themselves, because everything is bidirectional, we know how many pixels they are, we know what kind of colorimetry they have, and those show up on the UI. And so you can actually map the tiles in situ as they are physically cabled. So if I have a 10 by 10 array of tiles, I can map my 10 by 10 array in the mapping software. And then what the processor will do is it will intelligently know, because of the downstream network, it will know that, you know, tile number 1 is MAC address XYZ, because they talk to each other, and it knows that that's 100 by 100 pixels. And so what it'll do is it'll actually take like a tiny little pip of 100 by 100 pixels, and it will packetize just that section of video and put it out the network. So we're only burdening the network with the pixels that we need for the specific tiles that are on those ports. And then that goes out. And that's not, at that level, it's not 2110, it's our own protocol. I would say the video payload is sort of 2110-like, but we have certain timing characteristics that we need to hit to be able to run up to 1000 FPS and do some of the LED pulse width modulation that the timing on 2110 is not deterministic enough for us. So we embed some other things into it. But the video data is not all that dissimilar. It's just, you know, it may be 10,000 streams of data rather than a couple. Good question, John.
I didn't know how to phrase that exactly, but yeah, that was it. Yeah. Any other questions or? Yeah. Jed, Andy, you guys are good? Questions for us, Jeremy? Oh.
I guess sort of question, comment, statement is just we thrive on feedback, and our you know, the success of the projects that we work on are only as good as the features that everybody asks us to put in, and, you know, pushes us to push our technology. So I encourage anybody, if you see any of this technology, if you use it daily, if you don't use it daily, if you've got you know, anything that you'd like to see on a specific project of yours, let us know. And if it's a feature that we don't have, we'd love to understand why you need the feature and implement it for you.
Cool. All righty, well, I guess I'll wrap things up. Really appreciate it, Jeremy. Thanks.
Thanks so much, John. Thanks for having me.
I'll send you a link to the recording.
Awesome. Thanks. Bye, everybody.